All right, we're going to start with a small correction. Everybody's using both small and large models these days, so why don't we just start calling it GenAI Ops instead of LLM Ops? What do you think? All right, so just a little bit about me. I did all my graduate work in AI, and I built AI systems for a long time before running engineering for a bunch of startups. And then I worked with clouds to help startups build AI, because I love two things. I love AI and startups. So I'm only telling you this because I've had this amazing perch where I've had the opportunity to help some of the world's best startups be able to grow and scale with the cloud. And I've got this really unique view of sort of how these technologies evolve over time. You know, I had actually, the person who introduced me, I actually knew all the way from Databricks. I was Databricks' first customer. So it's been a really fun ride and really fun to learn all the different things that AI can do for your systems and all the different ways that this evolves. So if you're interested, please follow me on LinkedIn. I'll be talking a lot about GenAI and all the different tools that are out there and different ways that you can work with Microsoft to build new tools and new systems. So I'd love to start off with my own personal framework that I use to sort of understand where we are in this evolution of AI and how I expect to see AI application development change over time. So I call this my GenAI Horizons framework, and I think it's really useful to be able to go through and sort of see kind of what's coming next. Right now we're in this era of custom copilots, and copilots are amazing. You know, they help take long, complicated code, repetitive tasks, and make it so it's a lot easier to do those. They translate to multiple languages. They help you when you're stuck on a blank piece of paper and you want to know what to do next. They're really great for helping explore all these frontier models and all their capabilities. And you can have really tangible and important businesses by adapting existing workflows or helping solve long-standing problems in AI by using these models in an interactive way for your customers. But what comes next? I've already been able to see what I would call the GenAI native applications. And the big difference between GenAI natives and custom copilots is that GenAI natives are really good at doing what they say they're going to do. I can't tell you how many of the GenAI systems I've used, which I can get great results if I sit and I really try to go through and adapt to that model. But often, they don't kind of know three things about me: who I am as a user, what my data's like, and the context of which I'm working. And once you have all of those things, that predefined context, then you're able to have incredible applications. But I still might not want to use all of them if the costs are really high. And so the best applications really do a great job of balancing costs and abilities. These GenAI natives, as they keep developing their abilities and we start to learn how to trust them, they can start to form great GenAI systems. The big difference between a system and an application is that systems really help you scale value. They adapt to context of one another, and they understand cost and memory. Really, we want systems that are going to work safely and in order to be able to really understand what it is that they're doing with your data. If you're going to have an agentic workflow or automation, you really want to know that trade-off of, is this going to be able to be sandboxed in an environment safely? Is this agent going to talk about my social security number to another agent? What are those things? What are those trade-offs that are going to exist? How do we have a plan that's going to encapsulate the costs and be able to work in such a way that they can adapt the context for one another based off of what it is that I want them to have context and not more? Because without trust, you can't build GenAI systems. So how do we get from this great era of copilots to great native applications? One amazing company, and there are many in this presentation, is Harvey AI. And they solved this really long-standing problem that lawyers face, which is, how do I go through tens of thousands of legal documents and somehow use legal speak to find the document that I'm looking for? And this has been a really hard problem. And lawyers are a really difficult audience to sell technology to. If you're one of the startups that I've worked with, you'll find it really challenging to work with tons of different offices. How are you going to sell to this customer? The reality is that this was a problem that was really sore point for them. And I would say that they're a company and an area that is very adaptable to AI. Because hallucinations, it could be a feature. I mean, what is the definition of is anyway? Did any of you guys watch the debate last night? I kept asking myself the same question. So these vertical companies, they're incredible. I mean, Glean just raised an absolutely absurd round. This, infographic courtesy of Greylock, basically vertical custom copilots have had tremendous success, and the markups for companies who do well is outstanding. Sierra, they limit context. They do chat-based support, but they focus on triage, response, confirm, collect, search. All of these things help kind of narrow down what the user's experience is. So it's not an app that promises everything. It's an app that promises real, tangible value for your users. Glean, everybody's got TPS reports, and everybody's got a way that they talk about those TPS reports that's different in every company from another. You want to search with corporate jargon for your company. Incredible. These were long-standing problems, and they adapt existing workflows that everybody already had. Everybody already had search, but now they can search by limiting context. As we start our journey onto GenAI native applications, I'm really impressed by this company, Limitless AI. Their first version of their app was called Rewind, and it would sit on your desktop, and it would record everything you do to create your own personal CRM. It's amazing. It takes everything you do and say and uses compression technology with GenAI models that will transcribe all of your text and compress it 3,750 times more than a normal model. So you literally have to throw away nothing for the rest of time. Using this, they have a integration with the ASIC that's on your computer, and so they're able to really defer the costs of this model. Your text transcription works locally. If you want to ask questions of a foundational model like GPT-4, you can send that off to the cloud only if and when you want to. They've done an amazing job of balancing that trade-off of abilities and cost. And the reality is that every expert that I speak to across the board says the same thing. You're going to have to expect that there will be multiple models in the future. You're going to need to have some models that do certain capabilities at certain costs, and other models that have other capabilities at other costs based off of that context in your application. One company that I really admire is Flipkart, and they're India's largest retailer. And the way that they manage this is that they have different models all along the user journey that pass the entire context from one model to another. One model says, there's a blonde presenter. The next one says there's a blonde presenter who really loves tech gadgets. The next one says there's a blonde presenter who really loves tech gadgets that wants to buy an umbrella. This sort of stateless model interoperation is just one of those techniques, because we've already seen model routing from companies like Martian or companies like Artsy who go through and take all the different models you're working with and present it as a single model by merging it all together. One of the CEOs that I talked to of OrcsAI, IO rather, they're responsible for Netflix's Conductor, which is a wildly popular orchestration library. And he said, these models are great, but what happens on day 2 when you have to be in a new country? All of a sudden, you have workflows that are just slightly different from other workflows. You need to go through and understand what that operation is going to be like. And some of these tasks are going to be off of long-running queues, like emails. Some of them are going to need to respond immediately in real time. You're going to need to understand the whole orchestration of the system. So I like to think of it as GenAI systems have both all of the needs of your traditional DevOps plus all the different needs of your GenAI ops both together. Now your systems actually have to understand what confidence is in order to operate well. So I've had the great fortune in my position that I get to talk to hundreds of leaders across different companies. And so I interviewed a bunch of the leading companies in RAG and asked them, hey, what's coming next? What are you building for? What kind of problems do you want to solve for? I'm writing this with my co-author, Nick Giametti from B Capital, and actually there'll be a white paper that's coming out later. I'd love for you to join Founders Hub on Microsoft for Startups, or follow me on LinkedIn, and you can get the whole version of this talk and not just the slides. So please come follow me there for more. So let me break this down a little bit, because we're all at kind of different parts in our AI journey. And so what is retrieval-augmented generation? And by far my favorite example of this is when somebody said, it's an open book versus a closed book exam. Rather than hoping that the information that I'm seeking for lies hidden in the multi-layer perceptron of the probabilistic model that I'm calling. Instead, just have it go look at the documents in the catalog that you're using. As a result, it's like sitting in front and just actually looking at the source material. And this is great. Another way to think about it is it's like search. It just has re-rank, summarize. I want to fuse together disparate data types. And I think that really helps people understand kind of what they're getting out of this part of the technology. And RAG is great. It helps provide context, helps reduce hallucinations by grounding it within your own data, and it bypasses a retraining step if you're working with an AI model. So real simple. The easiest way to think about it is you can just think about it in the context of your prompt. So what are the benefits of using AI in healthcare? Then look through all of your company's healthcare documents, see what they want to say about it, and say, based off of the following document on AI in healthcare, insert the actual document into your prompt, and now answer the question. What are the benefits of using AI in healthcare? This really simple example is called in-context learning. And honestly, if somebody would have explained that to me from the beginning, it would have made it a lot easier to understand sort of how this technology works. So I love this minimal viable RAG by Ben Clavier. And what is so amazing for me is that it really simplifies it down to the least number of steps possible. I think it's 10 lines of code that you can go run at home. And basically it says you're going to load embeddings. If you're not familiar with embeddings, I want you to think of them as vibes. It's a lot easier way to say, like, Cadillac vibes kind of this way, Corvette kind of vibes kind of this way. Once you have that example, then you can run embeddings across all of your documents, all of your queries, and then you can compare them in a multi-dimensional space using cosine similarity search. And that will give you results. Where's the vector database? Well, in this example, that's NumPy. And the reality is that if you have a small number of documents in your catalog, there's no reason to have a vector database. You could do all of those coincide comparisons in real time easily. You have 5 documents, just load the 5 documents. You don't have to do that much here. So I talked to a bunch of CEOs, and I kind of asked them, and I learned a lot of lessons as I talked to them. And this one from Llama Index was really interesting for me, and it helps with all of the different startups that I mentor, which is you just don't want to let perfect be the enemy of done. What he taught me is you can get reasonably far using just a base layer. You don't even need a foundational model, and you can do this really cheaply. You can ask yourself questions like, are users actually getting, results for their data? Before you try indexing every single document type that you have, what is the context that you can get the most out of models right now? Match your business context with model capabilities. VectorDBs are incredible. And if it's appropriate for your use case, I absolutely want you to use a VectorDB. But the reality is that used naively, they can replicate upstream data. Why would I want 2 copies of my data when I really just want to have 1, right? The scaling law states that eventually the vector database in a simple implementation is going to become the bottleneck of your application. Then, of course, you have to respect whatever access and authorizational controls you have upstream of whatever happens to the database itself. So I talked to this company, Vectara, and he gave me my favorite analogy ever, which is he said, you know what, some people want the IKEA model of developing applications, and some people want the Home Depot version of developing applications. Basically, the IKEA market is the developer market, and the Home Depot market is this descriptive market. I really want to tell my application just what to do. He said, you know, in the end, when it comes to this data, there's no way to limit who can see it and who cannot see it. So you really want to be careful. Is that information of all of your company's precious data being integrated into the model itself? There's no way to prevent other people from being able to see that data later. There are major risks in integrating your data directly into a model. Enterprise production-ready applications succeed not only when they understand all the business context, but when they're intelligent enough to grant it to the right person for the right use case at the right time. So there are some really common problems when you build RAG applications, and it's usually around how am I going to handle knowledge updates. Because the reason you're using RAG in the first place is that you have data, and you need to be able to get that data into your system. And so you're trying to understand this external knowledge. You might be dealing with, like, how do I import it safely? Or when search takes it, I get all this corrupted data, just like my PowerPoint presentation was 5 minutes before this presentation. You have to handle all the compute resource. There's latency requirements, which, by the way, is the most common complaint that I get from people building AI native applications, is that they are really hamstrung by the fact that models take a long time to run. And of course, it can still hallucinate after all that work. I talked to Ragus, and the chief maintainer of Ragus said, hey, you know what? You have to think for real systems with real data. And so what does that mean? He calls it violation-driven development. At some point, you're going to have an application in production. You're never going to know if it really works until you expose it to your user. And it's got to be consistent, relevant, and safe responses. You're going to have production data of real users in order to understand that this system is going to work. And nothing that you do before you put it before a user is going to guarantee that you're not going to have hallucinations or wildly off responses. I can't tell you how many people ask me, so RAG or fine-tuning, should I be building my own model, as though there's a single choice to be made or one optimal solution. And if you go back and you read the original RAG paper, they actually use end-to-end machine learning to backprop loss across the entire system and not the language model. That means that they look at the documents that you're using as well as the language model itself, and then they run machine learning across the whole system. One of the authors, Dao from Contextual AI, calls this Frankenstein's monster. When you have frozen embeddings, you're using a frozen vector database, and you're sort of not adjusting for these things or helping correlate them. And when he wrote the RAG paper, he said, you know, I don't think the paper would have got accepted had it been just this naive implementation that most people use for RAG. In fact, I was thinking of it as only one small part of the system, and the frozen version was a hack. And so he says, I actually believe that the model is maybe 10 to 20% of an entire system or application. As we get to really large systems and we're trying to coordinate really big data, it's going to get incredibly complex. And things like how you ingest that data, you know, my Word doc is different than my Excel doc. I need specific parts of a PDF application. My company has hidden information within the documents that we're using that you would only know by the context of where it's located on the page. Embeddings, they can adjust for every single document that you're working with. They don't have to be frozen in time. And how you actually retrieve, you can use different kinds of re-rankers. You can have different methods of being able to lift the information that's most relevant for the context of which you work. So what's next? Well, I already told you at the beginning of the presentation. It's application development. You can tell I was working really late because I said, hey, Bing, what's the weather like in Alameda, California? And I just say weather, And it's not like Bing has gone off in its search algorithm, and then it's like looking through a bunch of documents to tell me what the weather is. That component is contextually aware. It knows the time of day it is, it knows where I am, and it's able to download specific information based off of that context, bypassing looking at any other documents. Really great systems, they use components, and those components are aware of their context. They can show source documents, they can attribute them to themselves, and they can handle things like keywords and filters. Users expect applications to be able to understand jargon. If you're going to build an application and you type in a keyword and it doesn't work, that's not a great application. And why would you have somebody type summarize if literally every single person is going to type summarize afterwards? By limiting to a component workflow and being able to validate that result, I can do things like cache prompt results. I'm able to go through and build tighter applications that are less latent. I can use other kinds of data sources and combine them into one system. So of course, the best practices are still loading. I really love this neuroprompts example, showing the difference between a human asking for a boy on a horse and a computer asking for a boy on a horse. You know, you can get wildly great results by not having an engineer write that prompt, but actually having another model write that prompt. By far, my favorite paper that came out uses, it's hard to believe, you can improve the mathematical results of your model by pretending everything's in the voice of Star Trek. Captain's log, star date, insert this date. We've had successfully plotted a course through the turbulence and are now approaching the source of an anomaly. That beginning will produce better mathematical addition than if you were to write that yourself. It's all about balancing trade-offs. There isn't one great way to build a GenAI application. Developers have to understand these trade-offs: model capabilities versus cost, information updates versus latency, flexibility versus user-driven context. In order to become a GenAI native application, you're going to have to be able to achieve predictable success. So I want to thank all the experts that volunteered to be interviewed for this presentation. And if you want a ton of credits, you want to learn more about AI models, or even hear more about this presentation in my white paper, please go sign up for Founders Hub. We paid for lunch, and so I'll say enjoy lunch, and thank you so much.